Hi, I'm Luke Kane. Welcome to Algebra 1. Today we're on the fourth part, the fourth objective of Chapter 8.1, simplifying rational expressions, and we're going to simplify a special case where we have a rational expression of the form a minus b over b minus a. And basically the idea is that b minus a, you can reverse the order as long as you multiply the whole quantity by minus 1. Or you can think of it as reversing the order and just putting a negative sign. In either case, what you're doing when you put a minus sign in front of the parentheses, or you put a minus 1 in front of the parentheses, means that you're going to reverse the order. So if you're going from right to left, minus the quantity a minus b, well, you flip the a and the b and you get b minus a, which is what you are on the left. Now, knowing that, if I have b minus a in the denominator and I have a minus b in the numerator, they're the greatest common factors of the numerator and the denominator. So if I divide each of them, the numerator and the denominator, by the greatest common factor, I'm going to get 1 over 1. So that I end up with 1 over minus 1 times 1, which is just minus 1. So that's basically it. We'll do a few examples, and then we'll finish up with writing equivalent forms of rational expressions in our fifth video. Alright, here's our rule, our special case, and here are examples of it that we will simplify or put in lowest terms in just a minute. But before I do that, I want to look at the denominator on the left, okay? b minus a. And I want to compare it to the denominator on the right. Alright, so I have minus a minus b. Well, that's the same thing as minus 1 times a minus b. And if I distribute that, I get minus 1 times a, which is going to be just minus a. And then I distribute that, and I get minus 1 times minus b. That's going to be a plus. 1 times b is b. Now I can put this up front. I can put this up in the back. I just have to be careful to keep the signs correct. So this is going to be plus b. Don't need the plus. Minus a. And guess what? That's the same as this. So we just demonstrated that this denominator is the same as this denominator. And since this numerator is the same as this numerator, this rule works. Pretty neat proof. Now let's do D. I have p minus 9 divided by 9 minus p. This is a direct application of the rule. So this is D. P minus 9 over 9 minus p. Alright, let's just look at our formula, right? So if I look at our formula, in this particular instance, a is the same as p, and b is the same as 9. So this formula is going to work. And you'll see it's going to work even without looking at the formula. It's going to be kind of obvious. Well, anyway, so this is p minus 9. Alright, I want to flip this because they are in reverse order. So to do that, I have to put a negative sign out front. Then I'm going to reverse the order, so this becomes p minus 9. Okay? And I just demonstrated that this is a legitimate thing to do. Now I have a common factor in the numerator and the denominator of p minus 9. So if I divide both by p minus 9, I'm going to end up with this. This is going to cancel, and that's going to become 1, because p minus 9 minus the greatest common factor, which is p minus 9, is going to be 1. And that's going to be 1. So I get 1 over minus 1, which is simply minus 1. And of course, when we looked at the formula earlier, I cut off this part. This can be extended. It's equal to minus 1 regardless of whether it's p or 9 or whatever is holding a or b. Alright, let's look at problem number 2. Problem number 2 is a little different. It's not exactly the reverse of the numerator is not exactly the reverse of the denominator, and we have a difference of squares in the numerator. So we have 16c squared minus 9, 16c squared minus 9 over 3 minus 4c. And this is e, as I recall. All right, let's demonstrate that this is difference of squares. This is in fact 4c squared. And 3 is the same as, I'm sorry, 9 is the same as 3 squared. My brain was going ahead of my hand at that point. Sorry about that. And I'm not doing anything to the denominator yet. Well, this is obviously difference of squares, so I factor that. It's going to be 4c plus 3, quantity, and times the quantity 4c minus 3. Now it gets interesting. And I have this 3 minus 4c. Well, these are almost the same. They're just in the wrong order. So if I put them in the right order, I'll be able to factor them out. So that's what I'm going to do. So this whole thing is 4c plus 3 times 4c minus 3 over. Now, for me to change this order, right, to move this up here and that back here and keep the minus sign, what am I going to do? I have to put a minus in front here. Again, that's my rule, in case you forgot. Here's the minus sign. That's going to reverse the order. Okay. So 4c comes first. Minus sign's still there. And the 3 is in the back. And guess what? I have a common factor. And the common factor is 4c minus 3. If I divide both sides by the common factor, or the greatest common factor, it's the only common factor, I get 1 over 1. So, or minus 1 actually. So technically this becomes quantity 4c plus 3 times 1 over minus 1. Well, I can simplify that. These are common terms. And this is going to become minus 4c plus 3. And if you want, you can distribute the minus. I don't really care one way or the other. Alright. Those two terms are equivalent. Let's look at the final one, f. Alright, what was f? This is f. Alright, you can see the numerator is, again, that's a difference of squares. Oh, look at this. We have a polynomial of degree 3. We haven't done many of those in class. Let's see if we can factor that little puppy. Anyway, so we got 36 minus a squared. Alright, 36 minus a squared. And that's over 2a cubed plus 2a squared minus 84a. Say hey, a. Okay. I think we got some factoring to do. Alright, as I said, this is difference of squares, so this is going to be 6 plus a times 6 minus a. If you don't believe me, FOIL those two binomials and you'll get 36 minus a squared. And, aha! I don't really have to factor a trinomial of degree 3 because I can factor out 2a. And what am I left with? Well, I'm left with a squared plus 2a minus 42. Okay, I got to do a little more factoring. I got 6 plus a times 6 minus a. Alright, 2a is still here, but now I want to factor the trinomial into two binomials. Aha! The leading coefficient is 1, so that tells me this is going to be a times a. The first terms are going to be a times a is a squared. Excellent. The last term is minus 42, so that means this has to be plus and minus, because that's the only way I'm going to get a negative number by multiplication. So minus 42 equals factor of 2 terms. And when I made a mistake. It's not 2a, right? That 2 gets canceled, so let's get rid of that. That was a mistake. Alright, that's just a lesson for those of you who write in ink. Make sure you write in pencil. So what two factors equal 40 minus 42, and when I add them, they equal 1. So m plus n is going to be 1. Well, I'm going to guess there's a 6, and 6 goes into 42 7 times. So I'm going to guess that the two factors are 7 and 6. And one of them has to be negative. But when I add them, they have to be positive. So the one with a bigger value is going to be positive. Right? That means this one's going to be negative. And sure enough, that's going to be minus 42 when I multiply them. And when I add them, I'm going to get 7 minus 6, which is 1. Alright, so I know the terms. So let's do a little factoring. I get 6 plus a times 6 minus a over 2a. Oops, forgot to put in the terms. This is a 7 and this is a 6. Okay. That's a plus 7. Now I've got this a minus 6 guy over here. Right? And I got this 6 minus a. They're in the wrong order. So I'm going to put them in the right order by putting a minus sign over here. And that allows me to change the order, to reverse the order. So this is going to be 6 minus a. Oops, not 6 minus 6, you doofus. 6 minus a. 6 minus a. These two terms are the same. So I have common factors in both the numerator and the denominator. I can cancel them out. If I cancel them out of the numerator and the denominator, they both 1. Or if you think about the fact that this is some number over the same number, that's going to be 1. In either case, I end up with 6 plus a over minus 2a times a plus 7. Unfortunately, there are no other common terms. I cannot reduce that anymore. So I'm done. Alright, let's finish up this video and go on to the last video in this series. So what did we learn today? Well, we learned how to simplify a rational expression that has the form a minus b over b minus a. This is the fourth in a series of 5 videos that covers the material in section 8.1 of our book. Now, the basic idea here is that if I have b minus a, I can reverse the order by putting a minus 1 in front of the whole quantity, or basically putting just a minus sign, because in either case what that does is it says if I distribute this minus 1 times a is minus a, which is what that is. And minus 1 times minus b is plus b, which is what that is. So this is in fact true. Now if I have this in the denominator and I have that in the numerator, well, I can reverse them by pulling this little trick. And these two terms are the same. They are common factors. Since they are common factors, I can factor them out of both the numerator and the denominator. This ends up becoming 1. That becomes 1. I have 1 over 1 times minus 1, which is 1 over minus 1, which is just minus 1. We did this with a specific example where a equals p and b equals 9. We flipped the denominator by putting a minus 1 in front of it. I'm sorry, we flipped the binomial in the denominator by putting a minus 1 in it. These two terms canceled because they're the same. It's like multiplying times 1. 1 times 1 over minus 1 is just minus 1. Alright, so since those terms are the same, we cancel them out. All we're left with is minus 1. Now, if you didn't get this, alright, if you're really struggling, there is, of course, another set of examples in the book than the ones that we just did. And those are a copy of that's bouncing around on the screen as we talk. Next time, we're going to finish up this section, finally. And I'm sorry it took so long, but it's a rich section. It has a lot of stuff in it. We're going to talk about writing equivalent forms of rational expressions. And essentially what we're going to do is the same thing we did in section 3, where we were writing rational expressions in lowest terms. Well, we're going to take low terms, not necessarily the lowest terms, and we're going to make them more complicated. This is going to be a necessary skill when we get to our next part, which will be about addition of rational expressions. Till next time, I'm Luke Kane. Thanks for watching. Bye now.